All right, welcome back. 7.9, last lesson.
Woohoo!
Woohoo! We made it. Okay, let's talk about horizontal and vertical lines. I should have chosen a color already, but late to the game here. Okay, so we're going to start with horizontal lines. Key information, they have a slope of 0. You should know that without having to think about it. So when we put a line in slope-intercept form, a horizontal line particularly, into slope-intercept form, it's going to end up with this y equals b form. But I'm going to talk a little bit, just quickly, why that's the case. So if you think about y is equal to mx plus b, and we just told you that the slope of 0 is always occurring on a horizontal line, then we know that we're saying that every horizontal line actually has this form of y equals 0x plus b. Now, we also know that 0 times anything is just 0, and we always like to keep ourselves most simplified in lowest terms and all that stuff in math. So 0x is nothing. It goes away, which leaves us with just y equals b. So that's where this comes from. Okay, also worth noting, in case you didn't remember, that the slope of 0 is because rise over run, and the horizontal line is not rising, so we get 0 over any amount of run. That almost looks like an alcohol, run. And we are going to then say that we always have a slope of 0. So just some side notes in case you weren't sure where that information came from. All right. Then we can take a look at this horizontal line that's in the example, okay? And so we can see that, as it says in the notes, this line is flat, and so it has a set height or a set distance above or below the y-axis, below the x-axis. And the point on the line here that we've highlighted 2, 4 is just an example, is only one of the many points on the line, but from any point on the line you can take the y value, so in this case 4, and then make the equation of the line from it, which gives us y equals 4, okay? So if you wanted to always choose the y-intercept, that would be fine. Of course, that would be the point 0, 4, and then again, you're just going to take that y value right out of the point to find the equation of the line, y equals b, so y equals 4. And then in general form, you can subtract 4 from both sides to get y minus 4 is equal to 0. Okay, enough talking about the written part. Let's actually do some math. We are going to take a look at the points given to you in the examples, and we're going to use them to find the equation of the line. We could do them in general form or in slope-intercept or whatever. I'm just going to stick with slope-intercept. It's kind of our standard. That's what most people would use talking about a horizontal line. So we have a point, 9, 4. And we're just going to take that y value. Okay, in this case, that's 4. And we're just going to set y equal to it. Again, remember that every point on the line is going to have a y coordinate of 4. And so that's how we know that the line is equal to y, which is 4. All right, I'll also do the second example, change things up. Usually we take turns. Today we're not going to. All right, so we have negative 8, 12. I'm going to take that y value. That's 12. We're going to set y equal to it. If you wanted a visual of what's going on, then we have 12 up here, and then every point is along this height of 12. And so that's where we get y equals 12, because y is equal to 12 in every point on that line. All right, who's next?
Me! Div. Literally nothing changes from what Mrs. Friesen said. We are going to take a look at our point. We are going to look at our y coordinate, and we're just going to set y is equal to negative 3 over here, because we get a horizontal line, right? Our slope is 0, so regardless of what x would be, that's going to cancel out. And same thing over yonder. Here we will have y is equal to negative 1. All right.
This principle gets maintained when you're asked to find the equation from the graph. You'll have to note that, okay, we'd be looking at some sort of horizontal line. We need to find then the equation of it. We know it's going to be y equals something. What is that y value? We could pick like any one of these points that's on this line. All of those will work. Whee-oo. Because y is at a consistent height the entire time. In this case, this height is 1, 2, 3, 4, 5, 6. Y is 6 over there. Y is 6 over here. Y is 6 everywhere. Y is 6. Same in this next case. Again, we know we're dealing with a horizontal line. We know that means we're going to have to say y equals something. What is it that y is equal to? Well, over here, y is equal to negative 5. Over here, y is equal to negative 5. No matter where we look, y is equal to negative 5. And that's how we do. Questions, comments, concerns?
No, I think we covered it.
Man,
Yay, us.
Yeah, we're good, hey?
We should almost be teachers.
Almost.
Worth considering.
Yeah, bit of a risk.
Also worth considering, vertical lines.
Ooh.
Solid segue, solid segue.
Thank you so much. Okay.
I want to ride a Segway.
Go to Chicago. They have them there.
Okay.
They probably have them here, too. That was just the first place I thought of.
Yeah, I don't really want to be honest.
Okay. Let's talk about vertical lines. They have a slope that is undefined. Again, quick review. Slope. Rise over run. In this case, you can see that every vertical line, just like the one here on the graph, has an infinite rise and literally 0 run. It does not go side to side at all. And you cannot divide by 0. That is not a thing we can do in math. So, because of that, we call it undefined. So, quick refresher as well on that. All right, now vertical lines, same deal as horizontal lines, except that now instead of being a constant height above or below the x-axis, they're going to be a constant distance left or right from the y-axis. And so we can see that the x value then will be a constant value, right? So we've highlighted this point 2, 4 for you, same point, but just a different line as the previous set of little mini notes there. But if I took any other point here on the line, I'm just like picking random ones to highlight, every single time we looked at that, it will be the same x value, although I'm realizing that we actually wrote the wrong point label on this. This is fake news, you guys. That's not 2, 4. Let's rephrase that. That's actually the point 5, 3. That's okay.
That was a test.
We passed. All right, so like I was saying, though, every point on this line, every point that I've highlighted here in the blue is going to have that same x value, and so because of that, we say that this line's equation is x equals 5, which we can see over here in the notes, and again, in general form, you can make that equal to x minus 5 equals 0. Okay, it's cool. I'm just going to do one example this time, because you guys have heard me talking enough today, and there aren't an even number of examples left. All right, so in this case, finding a vertical line's equation is the same process as a horizontal line, except that you just choose the opposite coordinate. So in the last page, we were choosing the y-coordinate. Now we're going to be choosing that x-coordinate, okay? So I pick that coordinate, and I just set it equal to x, and that is it. Again, because that vertical line would be somewhere here, and every point on that line would have an x-coordinate of 4. So then we have an equation, of the line x equals 4. It's done.
All right, I got the easy job today. So we are going to look at the next example here. We're following same with what Mrs. Friesen said. We are looking at our x-coordinate of our point, and because our x-coordinate is going to be the same for any single point on our vertical line, we just set x equal to that, so x is equal to negative 5. Ooh, that was a little funky. I don't like that.
Do better.
It's not worse. And here, same idea, is we take our x-coordinate, because our vertical line is always going to have the x-coordinate of 1, we are going to set x is equal to 1.
Oh, look! Some graphs. It's going to be a little wonky reading-wise. Like, there's a couple of things. There's this vertical line and this vertical line. Just make sure you can clearly see which one is your axis. It's the one that's labeled as your axis. There's your y-axis. Here's your x-axis. So clearly this thing-a-ling must be the line we're supposed to get the equation of. We can tell from the get-go it is a vertical line. As a vertical line, it must be of the form x equals something. But what is that something? Looking over, x has a value of 2 over here. My goodness, it has a value of 2 over there. In fact, no matter where we look, x has a value of 2. So I guess x equals 2.
It's a good looking 2.
Thank you. All my 2s end up different. I don't know. I have a bunch of different 2s. 2, 2, 2. Sometimes I've written 22 and literally done that. And I disgust myself. I know. Without even using a mirror. Anyways, last example. It's another vertical line. X equals something. What be that something? 1, 2, 3, 4, 5, 6, 7. It's always 7 to the left, or if you will, like -7. So I guess X is just straight up -7. Jiminy Crickets, look where that brings us. To the end of this example, to the end of this part of this entire chapter. That's the end of this entire topic. Ooh, there's another topic after. That's pretty neat. So, recommendations-wise, I would recommend practicing all these things. That would be a good idea. You'll probably see some questions get posted online somewhere at some point. There's probably even a chapter review in a textbook just after these practicey pages. It's probably worth a look. I don't know. See what's in there. See what happens. But above everything else, be good to yourselves. Be good to one another. And be excellent graphers. Anything you two want to add?
Nope.
No, we miss you.
You guys are awesome. Hope you're being safe at home.
We'll see you soon. Hopefully. Fingers crossed. Knock on wood.
Wait, do you cross your fingers because you're lying?
Because I'm hoping.
You're hoping,
We're
okay.
hopeful.
I'm hopeful.
We're
I say
honest.
it with my
Come
fingers
on, Mr.
uncrossed,
Thide.
and then I cross them after in anticipation and hope that they will come back.
We'll
just
see all
want-
these beautiful faces again.
I just want you all to know that she actually crossed her fingers.
I did it!